Hello again. I want to share something a smart scientist named Richard Feynman once said. He told his students, the first principle is that you must not fool yourself, and you are the easiest person to fool. And this idea is what we will talk about today. We are going to look at our own research paper. You got it last week. I said it was my paper, but you should still ask hard questions. And after we looked at different models, I said the numbers were there if someone wanted to check our work. So, well, today someone does want to check it, and that someone is us. I know how many of you have questions. Many of you asked validation questions 2 weeks ago, and we kept saying that question is for week 6. So this time is when we answer those questions. Many of you worry, what if I check my model very carefully and my numbers looks worse? Well, we will talk about this later. I think you will want to find those spots where the numbers actually looks worse. Checking out our work is not about finding what is wrong. It is about asking what would make each claim hold up. We will do this for ourselves twice. So how does a smart ML engineer reads a study? Uh, they do 4 things. You will do all 4 things twice today. First, you will say what the main idea is in your own words. Second, you will find where the label comes from, the answer the model is trying to guess. Third, you will figure out what the test design really checks and how they split the data. And lastly, you will decide which ideas the proof really supports. Last week, I gave you 3 questions to think about while reading. Which pages and parts of the paper show the main numbers? In each idea, telling us what happened, what will happen, or why something happened. And what real choice would this paper change, and how much? So keep these questions close, and also keep the paper and the ML Core Foundation Framework MD sections 8, 10, 12, and 13. Today, we will answer all these questions, and you are becoming the kind of reader we talked about in week 2. So you will be able to check the test, hunt for leaks, and ask what the baseline was. First, let's be fair. This paper shares information from many places. It looks at more than 340,000 pieces of information from 57 brands. And it also looks at 61,700 active records. And on page 2, it says the goal is to be clear and not to make the biggest claim. The paper shows how it makes its health score. It also says what the ML pages are just to explore ideas, and it does not give p-values or confidence intervals, which are the special numbers that show how sure you are. So nothing is hidden here. The smart thing to do is to read what the paper says its rules are, and then still ask more questions. So this will start on page 5. So let's look at page 5. The paper talks about health score, and that goes from 0 to 100. It is like a recipe made by hand. It uses impressions for up to 30 points, positions for 30 points, CTR for 20 points, and scroll depth for 20 points. And these are the 4 parts, and they always get the same points. This makes the whole score. And the page itself says this is a FlyRank summary score and not a regular market score. You know about this kind of numbers from week 4, I think. A product score comes from a set of rules. It might be a starting point or used to check out our work. It is not something we are trying to discover. This is why the health score is not in your project plans. Now, remember that recipe. At page 27, we use it. The paper uses an ML model called a random forest, and it asks, what helps us guess this health score? The list of things it looks at includes the 4 parts that make the score. So stop the video for 10 seconds and think about this. If an ML model is given all the parts of recipe and asked to guess the recipe, what will it find? Say it loud and can come back after 10 seconds. Look at the 4 biggest bars. They show average position, impressions, and how far people scroll and click-through rate. These 4 things are like the special parts of a recipe. Everything else, like clicks or how old our content is very small or 0. If you add the numbers for these 4 things, you'll get 98. And this means these 4 things are almost all of what makes something important. This is because the recipe uses only these 4 things to give a score. And you found out just by looking. You put page 5 next to page 27 and saw it with your own eyes. If you told the important things would be found, you learned what this lesson teaches actually. So what does the chart really show? It asks what makes content good, and the chart answer the recipe does. This is because we made the recipe that way. The chart just shows how the recipe works when you give it its own parts. This chart doesn't tell us new things about what makes content good. It just shows how an ML model puts a recipe back together from its own parts. It's like checking if a cooking machine can use flour and sugar to make a cake recipe. The paper does say this. It says the good content score is partly made from these things. So the chart shows what is there, not what causes it. And this is true, but it doesn't tell the whole story. We wrote that part and we use the word partly. But if you read it again, we think the word entirely. It will be much better. Partly makes you still believe in the bars a little, but entirely makes it clear that the recipe decided what was important. So to really learn what makes content good, we need to do more. We could try to guess things the recipe doesn't use, like how many clicks next month. Or we could use the good content score, but take out the recipes part. And then we would ask clearly if we are just guessing or checking the recipe. Page 2 of the paper actually gives the answer. It says to look at how well people search, not just the score. This helps answer your second question. The chart describes things, it doesn't show why they happen. And now, for the second thing we found on page 29. The paper says it guessed it correctly 71 out of 100 times. And this guess was made on content that was split into 2 parts, 80% to learn and 20% to test. That's all the paper says about how it tested its guesses. It doesn't say what was split, if brands were together, how many good things there were to start, or if it got the same results many times. The paper talks about 57 brands, but it doesn't say if all 57 were used there. So before you think about what 71% means, what do you need to know about how the test was done, and how many good things there were at the start? And there is a special line missing. We know about 80 out of 100 things went to each side, but we don't know which things were kept apart. If pages were split inside a brand, we would look at more pages from brands we know. If whole brands were kept out, we would see how well it worked for new brands. You can't tell from the paper which test was done. And here is a different example from your work in week 5. It's not from the paper. It's the same forest with 16,513 pages and the same parts. Precision of 50 was 0.996 when rows were picked by chance. It was 0.496 when whole clients were kept together. The base rate, which is what you just get by guessing, was 0.4162. Just changing the line changed the answer. And this example shows why the paper should say how it split things. It doesn't show which way the paper split them. So read the number again. The paper says one small thing. The logistic regression got 71 out of 100 right on a 80-20 holdout, taken from a sample or active content. It doesn't say how well it worked on a new brands. It also doesn't let you know if the score is much better than just guessing. What would make it mean more? It should say how it split things, how it grouped things, if brands were the same, how many things were in each group, the base rate, and if it was done more than once. And then it should say what each answer tells us. This is how to fix it, and everyone can see it to decide if it's good. So just 10 seconds. Say both things we learned in one sentence each. Say where the name comes from, and say what the split information does and does not show. And here the strongest part I said about our own paper today. Not good enough yet, not wrong, nothing bad. Because on both pages, we could say what the test does and exactly what would make each claim good. The assignment cards says it even better than I can. The paper was made for many people. It follows rules that are shared, and your job is not to grade it. Your job is to practice making your own work better. So let's go practice on your work as well. Okay, let's look at this closely. We asked our paper two questions. Where does the name come from? And what does the split really test? Now ask the same two questions about the model you made in week 5. First, one rule. Check looks at the exact information that was used for the claim. If you change how you look, it's a different claim. So today we use what you already know. Decision time is in May 1st, 2026. There are 16,513 pages from 36 clients. The base rate is about 42 out of 100. And the same 9 parts are used. June stays sealed, and we never open it, and nothing was carried over blind. Every number from week 5 in this video was computed to again this week, and it matched the saved recipe received exactly. Check how you get this first and then build on it. Now, let's do the check we told you about in week 2. I promised to show you how to split the information the right way, and that is in weeks 5 and 6. Week 5 showed the grouped part, and here is one test that looks forward in time. You train it earlier and use it in the same way and see what really happened next. Full test like this repeats it for many decision times. We have one here. So we trained the same plan on April 1st. And there were 70,611 pages from 29 clients. The base rate was about 51 out of 100. And then we checked the maze informations without changing anything. The forest found 25 real things that went down in its top 50. And the old rule found 13. Maze base rate is about 42 out of 100. So the forest is better than guessing, and the role is worse. The score itself changed, 51 when training and 42 when used. Things always change when you use them, and how much it covers the same way as the second thing we learned. This test This tests how things change from month to month. 29 of the clients used were also in the training, and 7 were not. The grouped part answered the question about new clients, and this answered one question about next month. It is a good proof, and we can still do more tests with many time windows. And there was a small difference. Before we said it looked good, but it wasn't for sure. So we looked at 5 groups of numbers. We took away the score from one rule from another score, and we did this 5 times. And you can see on the screen the answers there. 3 times the score went up, and 2 times it went down. The average was adding 0.104. How much can this average number change? We tried it 10,000 times by picking number again and again. We watched where the average landed. Most of the time, the average was between taking away 0.024 and adding 0.24. The number 0 is inside this. And this means the difference might not be real. 3 times one score was better, and 2 times the other score was better. So it's not always the same. These 5 groups of numbers are small and connected. We should use this to understand these numbers, not to promise what will happen next time. And what about the paper? On page 36, it says they did not report p-values or confidence intervals, the special numbers that say how sure you are. And they told us, and your work will go even further. Before you believe any difference between 2 ideas, there are 5 questions to ask. They are shown now word for word from section 8 of the core framework. Look at the tools you have. You started to learn them. You learned about trying numbers again today. You learned about one way to check numbers last time. You learned about looking at numbers from the past today. And this is not checking many past times. We check by client group, but we still need the numbers for each kind of client. We also need to try things online. And the last question is the one people forget. Does a better score on a paper mean better choices in real life? Bigger AOC score is not always the better model for the real decision. The review queue is the choice. And now, something important I told you about before. A long time ago, I told you about the secret problem in machine learning. It's when the model quietly looks at the answer while it's learning. I said we would talk about it later, and we learned about the trap before. And this is the time to talk about it. For your own model, you can check it by looking at the timeline. Here is how to do it. Find the news date for information, like April 30th. The time we are looking at for the answer is May 1st to May 31st. Make sure all the 9 pieces of information the model used are known by the time it has to make a choice. And we checked this with code, and not just by remembering. The click in May are part of the answer, and the views in May are not part of the answer, but they come from the same months as the answer. So both stay locked out of the feature list. IDs are for grouping, not for learning from. And there is one thing to remember about who we are looking at. We only look at people we saw in May. Out of 60,513 pages we looked at, 60,412 have numbers from May. And the one page that is missing gets 0 clicks. And this means it counts as going down. And you must show all of this. Answer can sneak in 3 ways, and now you know them. 1, information made from the answer itself. and this is a column made from what you are trying to guess. It's easy to check, train the model with it and without it. If the score drops a lot, you know it was cheating. Two, future information. This is any information that comes from after the model makes its choice. The timeline helps you find these. Three, information from another system that already made choices. The rule from before, which we paid for, is starting point to beat. Never something the model should learn from. And if you put in a bad piece of information on purpose, your score should go up a lot. If it doesn't, your checking tools are not working. And Jew numbers would stay secret. So to prove something is true, you need the person who set up the numbers and the file with the scores. There are two more words to know. We talked a little about why things happen before, and here is why they happen, what they mean. Prediction, which is guessing what happens next. Answer this. If we see something, what will probably happen? Causation, which is making something happen. Answer this. If we change something, what will happen because of that change? And these are different questions. Everything we talk about today is prediction. The chart on page 27 just tell us about how the model acts. Your decline Q is a prediction, and nothing in our numbers or the paper shows causation because nobody did a test to change things. So remember these two ideas. They are very important. So this is about fixing a sentence that made a big claim about our week 5 work. Our old sentence was like, our model is right 50% of the time, which is better than the or rule. So it will help any customer next month, and fixing pages it points to will stop them from getting worse. But there is a problem with this sentence. 50% right sounds good, but we should also say that just guessing is right 42% of the time. Our model was only a little better. 10 points better also sounds good, but sometimes it was a lot better and sometimes it was not better at all. We need to say that it could be a little less good or a lot more good. Any client claim is too strong. Different customers had different results, so it might not work for everyone. Next month claim was only tested one time. We need more tests to be sure. We'll stop them from failing claim. Means our model causes pages to get better, but we did not do a test to prove that. We just saw what happened. So we made the sentence much shorter and cleaner using 4 main words. Observed, we just saw what happened. We did not do a special test to make it happen. And we have numbers for everything. We can show how we got them. And most of the time, things got better directional, but sometimes they did not. So it shows the direction, but not always a perfect path. About the decision support, our work helps people decide what to do, and it does not tell them what will happen for sure. It does not say why pages get worse. It just helps them choose pages to check. We also need to say how big the change was. That's very critical part. Our model helped find about 5 more good pages out of 50, but it did not always make things better. So now let's use your AI assistant to check your model. The old rules are still the same. So first learn the idea and then use the assistant. And there are practically, you can have 5 steps. 1, you will write down your main ideas. and what is your work about, what numbers did you use, what is the main thing you want to say, and you need to know what you are trying to protect from being wrong. Then tell your assistant to find mistakes, give it a job, ask it to prove your ideas are wrong, and one idea at a time. After that, test the assistant's ideas. If it says something is wrong, you need to change your model and see if the numbers actually really change. An assistant that just guesses is actually not good. You need to find out by yourself. So 4, you are the boss. You always decide what is right and what is wrong. The assistant does not choose your numbers or what you share with others. After that, you will keep your ideas, but only good one. If you find a mistake and fix it, remember that fix for the next time. Your next model will already know about it. So we used steps 2 to 4 on our own work today. And it's like getting a second opinion, but even better. So ask the assistant to challenge you, not just to tell you everything is fine. And here is your homework for your ML9, and it will take about a few hours, maybe. You already have the basic plan. It has 5 parts. So one, find 2 things in our FlyRank research paper, the PDF you get in week 5, not the paper you will write yourself in week 8. So just to be clear. And what did that paper find? How did they get their informations? How did their tests really show? You can use examples from today or find your own in the paper. So for example, you can ask it if the number of words change in the middle, not just the average. You can also ask if the age of things shows a full life or just the ones that lasted. After that, show your model working, show your model when you group things differently or look at them over time, show what happened before and after. 3, check for mistakes, look for any ways your model might have gotten help it should not have. 4, rewrite your main ideas, use the 4 clear words we talk about today. And lastly, check your own work, make sure everything is correct. If you use an AI assistant, make sure you read skills MD files as well, README file. So here are some quick answers. What do you turn in? The link to your work, just like every week. What information do you use? The same information you used for your work in week 4, 5, and previously. If you change something and you have another direction about your research paper, you need to go step back and redo everything. But you have an AI, you have an assistant, you can change your ideas and directions many times. It shouldn't be a problem there. How much work is enough? So 2 findings with questions, 1 before and after check, the list of checks with a timeline, and 1 main idea written with the 4 safe words. More work is fine, but not mandatory. And don't worry if your numbers look worse when you check them in a stricter way. And that means actually your work is doing what it's supposed to do. It means your first guess was too hopeful and now it's more correct. So write down the stricter number and explain why it changed in 1 clear sentence. And that's the skill we want you to learn. Getting a bad result, but explaining it well is a still good thing here. Actually, very good thing. And we still have 4 things to work on from week 5. And we looked at just 1 future time today. We still need to do more tests over many different times. We know that our model can guess things, but only a real test can show if it causes changes. And we will talk about making your work ready for real use in week 7. And that's when you check the ideas become a plan for action and your big project becomes something people actually read. And we still need to make sure our model guesses are very accurate. It is important to say out loud when things are not perfect yet. And one last time, the main idea. You can stand by what you say when you show how your work was done. And you only say what your information truly shows. If it's not ready yet, you write down what still needs to be done and to make it clear and true. So you check if your work will become how we did it, and what we still need to learn. That these parts will be always there inside of your paper. And people who read your paper will look at it same way we did today. And so your work is waiting. Ask me any questions in the comments or on the assignments. Next week we'll start by answering them. And first principle is that you must not fool yourself. After today, it will be much harder to fool yourself. So see you in week 7, and bye.